In our derivation of anions, I will only move straight. We have various principles: action of heat, action of dilute HCl, action of comp H2SO4, and so on. Then we have the confirmatory test for anions, where we test for SO4, SO3, NO3, Cl, and so on and so forth. So we're gonna deal with that one. I think, yeah. It's a lot. Okay. Now, in a derivation of anions are negatively charged ions, normally ions of non-metal or group of non-metals, that's the acid radicals. The following anions are to be identified, which we're going to focus on: triazocarbonate 4 ion, the CO3 2-, hydrogen triazocarbonate 4 ion, HCO3-, triazosulfate 4 ion, SO3 2-, tetrazosulfate 6 ion, SO4 2-, triazonitrate 5 ion, NO3-, chloride ion, Cl-, bromide ion, Br-, iodide ion, iodine-. The anion present in an inorganic substance can be identified as follows. We have it by action of heat, 1, by addition of dilute hydrochloric acid, 2, by addition of concentrated tetrazosulfate 6 acid, 3, by confirmatory test. That is by precipitation, which is by the addition of suitable reagent to the solution of the substance. Step 1 to 3 are meant to produce gases that can be identified. All right? They provide useful information about the anion present. Example, the identification of SO2 indicate the presence of SO3 2-. So we are going to take on the last one, which is the confirmatory test. Now, in the confirmatory test, like I said, we are testing for SO4. We're going to test for SO4, SO3 2-, NO3, Cl, CO3, and so on. So we're going to start with the test, observation, and inference. So take note, in the test for SO4, we will add our barium chloride solution, we'll get a white precipitate is formed. We have various other anions that we are suspecting. Then when we follow that up with dilute HCl, the white precipitate is insoluble in excess of dilute HCl. And SO4 is confirmed because SO4 is not soluble in excess dilute HCl. But when we are testing for the SO3, now we added the white precipitate, which all of these two are also involved in the inference. But when we added excess dilute HCl, the white precipitate is soluble in excess. We have SO3 2- and CO3 2- probably present because these two guys are soluble. We'll continue until we be able to single out this particular one only. So this is our B. So let's see what happens to the C. I'll clean. Now in C, to another solution of 2, few drops of dilute HCl was added. Okay. Was added. So now, the C, to that solution we add few drops of addition of few drops of tetraoxosulfates, dilute tetraoxosulfates, followed by the addition of KMnO4 solution. The purple color of KMnO4 turns colorless as potassium tetraoxomanganate 7. It turns colorless, so SO3 2- is confirmed. That is the confirmatory test for that. So we're done with our 2. Let's test for triazonitrate 5 ions. So I can take out this. Number 3. So test for this, we say to a small volume, before we proceed further, let's take note. We've tested for SO4. We say to that solution we'll add barium chloride, we get a white gelatinous precipitate. We have SO4, SO3, CO3, all of that present. Or suspected. Now the B, we say that is followed by addition of excess dilute HCl. The white precipitate observation, the white precipitate is insoluble, and we say SO4 confirmed. Now in the test for SO3, what do? We still added barium chloride. Okay, when we add it, we get our white precipitate, and the observation is SO4, SO3, S2- and so on present. We follow that by adding dilute HCl, where the observation is soluble. We have CO3 and SO3 present, probably present. And we move further to add dilute HCl in drops and followed by KMnO4. Now we say that the observation, what do we say? The purple color of KMnO4 turns colorless, and the inference we say SO3 is confirmed. So we have just run the test for SO4, SO3, and now want to test for HNO3, which is NO3, triazonitrate 5. So you should know the various tests and the observations, what you get in the observation of all the anions. If I ask, for example, how do we test for SO4? You tell me to the solution or the sample given to you, add aqueous barium chloride. What do you get in observation? You get white gelatinous precipitate. In the inference, we have a whole lot of them, SO4, CO3, and so on. Then you proceed further. Do not stop there. You proceed further by adding, followed by the addition of excess dilute HCl. When you do that, the precipitate is insoluble, so SO4 is confirmed. So you should know these things offhand. So let's test for the NO3 triazonitrate 5. We say to a small volume of the solution, add a little freshly prepared ion 2 tetraoxosulfates, sulfate 6, we are testing for NO3 NO3. Slant the test tube. Slant the test tube to one side. And very carefully pour concentrated H2SO4 down the wall of the test tube. Ensure that they don't meet. When that happens, observation, brown ring is formed at the junction of the two liquids. Observe the inference, NO3 minus is confirmed. So that's the test for NO3. We've experimented the test for SO4, SO3, and now NO3. There are other ones which we're going to run as time goes on. Let's see what we can do. So we say for NO3, we should add a small volume of the solution to a small volume of the solution. We should add little freshly prepared iron 2 tetrazosulfate 6. Okay. Now when we add a little iron 2 tetrazosulfate freshly prepared, we slant the test tube to one side and very carefully pour H2SO4 down the walls of the test tube. We should not allow it to mix. What happened? We see a brown ring is formed at the junction of the two liquids. That is the test for NO3. So NO3 is confirmed. As soon as, wherever you see that, they say to a small volume, add freshly prepared iron 2 tetrazosulfate 6. Now, why do we use freshly prepared? Because when you prepare your iron 2 tetrazosulfate 6 and keep it, it will be oxidized to iron 3. So it has to be prepared immediately and used. So that is what it is. So for now, or today, we're going to stop here, all right, and see what happens in the next other tests. We're going to have a whole lot of them. Tests for bromide, for iodide, chloride, and so on and so forth, CO3 and so on. So we'll see what comes out on the next experiment. Thank you.